Hello, welcome to another video in the calculator tutorial series. This time we'll do simplex method for maximization. It is in the calculator tutorial because we're going to use the calculator to simplify our calculation. Also, we're going to use the row operation. I recommend you to read to see what we did on the second video before we do this. Anyway, so we try to maximize a function. So this is the function, objective function to be maximized. So that function to be maximized, and we only do maximize here. This will be the system of inequality, or we call the constraint. The constraints. Except for the x and y greater than or equal to 0, we really don't need that, because under the assumption we assume all the variable will be non-negative, so we're going to have that. Also, the simplex method kind of have many steps, so you should read what we have above. Anyway, so what we start by the system of inequality, these two. It is inequality, but we're going to turn that into equation. We're going to add something to that. So they are non-negative and add up to 12, so we're going to have to add another number. We call the slack variable. We call that S1 for the first equation, and then after that we can make it equal to. So if it's not equal to, we add something to make it equal to. So this also to be determined. This second inequality, we're going to add S2 that, so we can make it equal to 18. And those are called slack variable. And then the objective function will turn that into a equation as well. So objective function we will minus x and y to the other side. So we will have z minus x minus y equal to 0. Now this is the system of equation. We're going to put that in the matrix. So this is exactly like what we have before, right? So, however, we have quite a few variables, so we should label them. So this column is going to be x, y, we have S1, S2, and then z. And then we have the equal sign, so we separate by a line. And then that. So our first equation, 2x 3y 1s1 0 0 equal to 12. 4x 3y s2, so there's no s1 or z, it's going to equal to 18. And then we have minus x minus y zero s1 0 s2 1z equal to 0, right? We will separate the last equation for the objective function with the constraint. So we draw a line here as well. So first we look at this, and we see those are the indicators, and we look for the most negative one, the most negative numbers. So since both are negative, you can just choose whatever works. So I will pick let's pick this one. So we're going to use this column. After that, we'll divide the last column into it. So 12 divided by 2 is going to be 6, and 18 divided by 4 is 4.5. So according to that, first we're going to pick the most negative. They are the same, so we just pick one. That will give you this column, and from this column we divide the last column into it, except we don't do that for the last one. And then if we pick the most negative here, we're going to put the least positive. So most negative, least positive, which is this one, which is least positive. Because those go together, we have this element, which will turn this into a 1 because we need to pivot that. Once we turn that into 1, we can turn the rest to 0. So this will go to 0, and this will go to 0. Right. I'm going to do all 3 steps at once. So now calculators. I'm going to put this augmented matrix into the calculator. So second matrix, matrix A. This is going to be 3 rows and 6 columns, 3 by 6. Right, 2, 3, 1, 0, 0, 12, 4, 3, 0, 1, 0, 18, negative 1, negative 1, 0, 0, 1, 0. Right, let's see it. Alright, then we can use the row operation on this matrix, or we call the simplex tableau. Right, so in order to turn the 4 into 1, remember in this case we cannot swap rows because we want that particular to 1. The only thing we can do is divide by 4. So we're going to do 1/4 row 2 into row 2. When we do that, that element will become 1. If it is 1, then we can turn the order to 0. So we use opposite of 2 multiply to the row that has the pivot entry, add and replace into row 1. Sorry, pivot entry is in row 2 into row 1. And we use the opposite to this, which is 1, multiply to row 2, add and replace to row 3. Right, we're going to do all 3 operations one at a time. So program RowOps, we choose matrix A. That's what we want. Exactly what we want, right? First, we do this. So option number 3, multiply row 2 by 1/4. Right. Don't worry about the fraction. We have to deal with it hopefully later. Right, so we have 1. And now we just keep rolling with this 2 operation. So option number 4, multiply row 2 by -2, and then add to row 1. Notice that this is not the Gauss-Jordan elimination, so we cannot use the RIF. It's not going to help. We're not going to get anything. Alright, after that we're going to turn the last entry to 0, so we multiply row 2 by 1 and add to row 3. Now we do have 0, 1 and 0. We should copy this down. So 0, 1, 0, 3 half, 3 fourths, negative 1 over 4, 1, 0, 0, negative 1 half, 1 over 4, 1 over 4, 0, 0, 1, 3, 9 halves, and 9 halves. Right. Of course, we have the variable too: x, y, s1, s2, and z. Right. We continue. Notice that now that we have the 1 here, so this is what we call the basic column. So for the basic column, when we have the 1 here, we just go ahead and write out this x is going to be here as well. And the end result, x is going to be somewhere in here. It's probably not this, could be something else. Right. We will continue in the simplex method. Now we look at the indicators. The most negative here is going to be in this one, so most negative. And then we divide backward. 3 divided by 3 halves. It's like multiplied reciprocal. So 3 times 2 over 3, which is 2. And then 9 halves divided by 3 fourths. Again, multiply reciprocal. 9 halves times 4 over 3. So it's going to be 6. Right. Now we look for the most negative in the column and the least positive in the row. So this is going to be this. That is least positive. So this is going to be our pivot entry, which will turn into 1, and the others in the columns to 0. Right. I'm going to write out the operation and then we do it all together in the calculator. So first, to turn this to a 1, we have to use the reciprocal. Instead of 3 halves, we're going to have 2/3. So 2 over 3 times row 1, we put into row 1. And then this to 0, which we use opposite. Now we will multiply to the row that has the 1, which should be in row 1 by then. Then we'll add row 2, replace into row 2. Right. Now that we use the opposite. We add to the row that has the 1, and we add and replace into row 3. Right, we're going to do all 3 of them together in the calculator. Right, so hit enter to continue. Multiply the whole row by a number, that's option number 3. So multiply row 1 by reciprocal of that, so 2/3. That's it. We have that. We ignore that for a moment. We're going to do this operation. So enter to continue. Going to be option number 4. Multiply row 1 by -3/4. Add to row 2. Still have fraction, don't worry. And then 1/4 into row 1. So also this option, multiply row 1 by 1/4. Add to row 3, and we have that. Now we copy that result. Right, so zero, 1, 0, 1, 0, 0, 2/3, -1/2, 1/6, -1/3, 1/2, 1/6, 0, 0, and 1, 2, 3, and 5. Sorry, just copy from the calculator. So this is what we have, and actually we done already. Now we focus on the matrix. So the variables, we have x, y, s1, s2, z, and then the constant. Notice that on the previous example, we do have, on the previous step, we do have x on the second row, so we still have x in the second row. And now that we have 1 here, and it's in the y column, so we're going to put y here as well. Now we look at this, we see all the indicators, all of them are positive. So no more negative indicators. So no negative indicators. So we're done. Right. How do we write the result? In the result, what we see here is this column we have 0 and 1. This column we have 0 and 1. This is not. This is not. This we have 0 and 1. So this is going to be the basic column, and basic column. Actually, if this is basic, now you can also write the z. It's going to be the values here as well. So those are the basic. Those are the basic variables. What we see is that y is going to be 2, x equal to 3, and z equal to 5. So we write x equal to 3, y equal to 2, and then z equal to 5. The others are non-basic. We will let them equal to 0. we let S1 equal to 0, S2 equal to 0. So we see that the maximized values for z is when x equal to 3 and y equal to 2. Sorry, it should be 5. I don't know where that comes from. So maximized values of z is 5. That when x equal to 3 and when y equal to 2. So that is an example of simplex method. Most of the calculation we use the calculator. It's kind of like the Gauss-Jordan elimination, except we do not do any row swap here, and the one is not in the reduced row echelon form. We still do it in the elimination, but the goal is different. We try to get all the indicators to something that is not negative. Right. I think I will only do one example in this video because this is very long and tedious. I think it's better just to do one example, and then you might want to go back and watch this again, or check at each step what we have above with what we have. So I'm going to stop the video here. I hope this helped, and thanks for watching. Hello again. Now we will continue to do one more example of the simplex method for maximization. So that's why I named this the calculator tutorial 3B. It is another example in the simplex method. Right, all of the material still up there. Now we will go through this example. So we start with the linear inequalities. Right, and then we'll add the slack variable. I'll just add S1 for the first equation, and we make that into equation. Right, and the objective function we move that to the other side. It will become negative 5x negative 5y plus p equal to 0. And then we'll have the simplex tableau, or the augmented matrix. All right. We should label the variables and the slack variable, also the p. Right, and we put this augmented matrix into a matrix. Right, also 3 by 6. 1 2 1 0 0 32 3 oops 3 4 0 1 0 84 3 oh, we already have that. -5 -10 so 1 0. Right, let's see what's that again. 1 2 1 0 0 32 3 4 0 1 0 84 -5 -10. Right, it's right. Now we look for the most negative indicators. Will be this -10. So again, I'll write most negative. And then we divide 32, divide by 2. The last column, divide into that column, that pivot column, give you 16. 84, divide by 4, that is 21. And we're going to pick the least positive. So that will be the pivot entry. It's going to be here. We will turn that into 1, and the others to 0. Just like the last example, I will just put all of this in one step. So to turn this into 1, we take 1/2 the reciprocal of it, multiply by row 1 and put in row 1. After that we will have the pivot row, which is row 1. We use the opposite to those numbers. To eliminate 4, we use -4. Add and replace row 2, row 2. Opposite to -10 is +10. Add and replace to row 3. Right, now we use program RowOps and enter. So the matrix A. Right, enter to continue. Multiply a row, that is option number 3. Multiply row 1 by 1/2, oops, 1/2. So we have that. Going to be 1, which is good. Now those 2 zeros. Option number 4. Multiply row 1 by -4. Add to row 2. So that's 0, which is good. And then enter to continue. Also option number 4. Multiply row 1 by 10. Add to row 3. And we have that. So this is what we have. And we write it down. Right. Copy the matrix 1/2. 1 0 1 0 0 1/2 -2 5 0 1 0 0 0 1 16 20 160. Right, let's check again. 1/2 1 0 1 0 0 1/2 -2 5 0 Alright, now let's label again. Notice that now we just pivot by that entry, so now we can write y is going to be in this one. And here maximum of p equal to 160 happen at x. X is non-basic because we don't have the 0, 0. So in that case we have to say x. Okay, let's just say it for the basic first. So basic variables, p is basic 160, s2 also basic, it's going to be 20, and this is a basic column, y equal to 16. Right. So that's definitely a solution. However, what we see here is we have s2 is equal to 20. So if we go back to the equation here, and s1 to that basics and then basic, we have x is non-basic will be 0, and s2 is basic, so s1 is not basic. So that's what we have at the moment, because we have x 0, y 16, and p 160. However, what we see here is that even though we have no negative, if we want to, let's just try and say, because now we want what happened if x is not 0, can we have another values for x? So we just try in here. So we're going to pick, still we're going to be pivot around that one, so still pick this one, because hopefully we're trying to get some values for x. So pick this column because that will give you the values ultimately, and then we'll divide 16 divided by 1/2, that will give you 32. I should not write that here, so continue that again here. Let me just copy this first. So 1/2, 1, 1/2, 0, 0, 16. Right, label x, y, s1, s2, p. We do have the y values is going to be equal to 16. That's the basic. Right, not going to touch that. Right, now we want to have the x values, so in that case let's pivot around this column, so we might have some different values for x, and now we do that to see what happened to the profit values. So we divide 16 divided by 1/2 give you 32. 20 divided by 1 is 20. So although it's not most negative, but we want to see what happened in the x values, so we do that. And this, however, is the least positive. Right, so we have the pivot entry here, which is good. So we're going to keep that. And so we have 1 already, which is good. All we need to do is turn this 1/2 to 0. And that, okay, good, still on the calculator. Right, so all we need to do is use the opposite to the 1/2. Opposite multiply by the row 2. We add and replace to row 1. Right, we do that. 4 multiply row 2 by negative 1/2. Oops, sorry. Multiply row 2 by negative 1/2. Add and replace to row 1. Alright, now we have that. Now let's copy this down. Right, now let's label again. X, Y, S1, S2, P. Right, earlier we have the Y there. Now after we pivot around this entry, we also have this going to be X. So we're going to put X here because that is the pivot entry. So it's going to be X. Now we have the basic X, Y, and P. So we have basic, variables. We have X equal to 20, Y equal to 6. And this will be P equal to 160. Now we do have X and Y. The non-basic, we will let equal to 0. Now we compare the values of those two. So let's see. Right. Earlier in this step, I'll just write the X and the Y values only because the slack variable not really important. So if X equal to 0, Y equal to 16, and the P is 160. That's what we have on that state. On this state, we have X equal to 20, Y equal to 6, and P equal to 160. Notice that both times the P equal to 160. So in this case, we have more than one solution. And a theory in linear programming that since we have two values, maximum values at the same 160, at these 2 points. So we will have the maximum values on the line segment connecting those 2 points. So the final answer will be as follows. Or from 016 to 26, and it will be the whole line segment. So from that point to this point. So this is an example where we use the simplex method and we end up with more than one solution. Usually we want to have the values of x and y, so that's why when we have something like this and we think that we can go further and try to find if it's possible to have all the x and the y values as well. So now we have another example in the simplex method. I will add this video into the previous video and just make one video all together. Once again, thanks for watching.